Okay, we've just taken a look at the Asus Hyper M.2 x16 quad card. Now we're going to take a look in this video at the Gigabyte Aorus M.2 x16 quad card. Thanks for joining us. So we're going to need to get the Asus card out because we've got the memory we got to pull, and we'll put that on the Gigabyte card. That's our next step. And you will probably not see the memory swap, but you will see the memory once it's swapped out. And I'll get into the specs on the test machine once we get to that point where we're ready to do the install. Out comes the Asus. Out comes the Gigabyte. It's interesting, on a pound for pound basis, I can definitely feel the weight difference in the Gigabyte versus the Asus. It's that heat sink. I'm eager to see what this is going to turn out to be. It's going to be fascinating. Asus. I got to tell you, I'm getting quite adept at changing out these drives on these cards. I've never changed drives so much in a machine as I have this one. But we're all about answering subscriber questions, so that's what we're going to do. And as a result, we've had some questions about comparing PCI Express 3.0 on the speeds versus PCI Express 4.0. So we have a particular card that I just haven't gotten around to showing you guys, that to answer that subscriber question, it has a PLX chip on it. We're going to be looking at that card later on, because the PLX chip will determine the speed no matter what the drives are. Okay, that one, man, those pads stick. Heatsink, and from the last test we still have in the first and second position the WD Black SN850, the Samsung 980 Pro, and the two Sabrents. Okay, for our first test we're going to have 4 Sabrents, and those drives are all first generation PCI Express 4.0. These two drives, which are each 1 terabyte, these are second generation PCI Express 4.0, and because they're second generation, we're going to get different speeds. So from these, we're going to get 5,000 megabytes, and from these, we'll yield about 7,000 megabytes. And what we'll get a chance to do in the first test is with these 4 drives, see how they test out for heat. And the numbering, again, is 1 through 4 on the Asus card, and then these 2 drives, we'll see how they compare with the other 2 drives that are going to be in that spot. So to reiterate, first test, 4 drives, all 4 Sabrent rocket. And this one on the Gigabyte card, I cannot use a number 1 Phillips. I have to use a micro screwdriver. We've also been asked, have we tried 4 of either of these cards in a machine? No, we have not. Why? Because you got to have a workstation, a WRX80, to have the resources for the lanes and slot assignment to make all that work. This test machine is the Gigabyte TRX40 Designare. So we have 2 16-lane slots and we have 2 8-lane slots. And these cards are quad cards, so 4 drives, that's 4 lanes per drive, 4 times 4 is 16, that's 1 16-lane slot. So theoretically we could do 2 of these cards in a TRX40. But to reiterate, to do 4 of these cards would require a WRX80. Unless you want to do PCI Express 3.0 on the X299 chipset on an Asus workstation class motherboard on the X299 that would have a PLX chip to give you the lanes. But we're not doing that. PCI Express 4. And we have to think about PCI Express 5 is coming. So we're at the point now where we have access to PCI Express 4.0, let's call it 3rd generation drives, that are good for about 71 to 7200 megabytes on the read and almost 7,000 megabytes on the write. That's wicked. But that's not these drives. These are first and second generation drives, PCI Express 4.0. But if we get a chance to test one, we'll look forward to it. That's the plan. Now, again, we'll do this like we did the one with the Asus. Nothing about RAID. RAID is a function of the motherboard BIOS. All we're doing is heat and speed. So the 4 things we do: unboxing, we don't have. Inspection, we're kind of working on that. Then we'll do the installation, which is pretty quick. And then number 4, we do the test. And we'll have 1 test with 4 drives and a second test with 2 drives. Overhead. I like the attention to detail that Gigabyte has given this card. For example, on the back of the Asus, I've got a PCB and I've got a heatsink on the front. Whereas on the Gigabyte, I've got a metal plate on the back, like a stiffener. And then I've got the heatsink on the front. And to reiterate, the black tape was for the emissivity readings we were attempting to get with the FLIR thermal camera. 1 nice big pad with 1 nice big pad. The heatsink on this is copper, and that's 1 pad. So if we were to replace that to get a better reading, it's doable. Okay, the drives are labeled on this one. from the bottom up, 1 through 4, whereas on here we had them from the I/O panel on the left, 1 through 4. Does it matter? I'm just pointing it out. I'd zoom in further, but I've got to have a little bit of room to work, and I thought you might want to be able to see both cards if we even show it. And the 2 spare drives are going to rest in the Supermicro dual M.2 NVMe adapter so that I can keep them close at hand. Now this is also a thermal pad, so we have a thermal pad on the bottom and a thermal pad on top. I like the way Gigabyte has laid this card out. Also, you can tell we have a little bit bigger fan. I thought I should point that out, because if I don't, somebody else will. But anything I miss, you guys mention. And we still have an ASRock quad card to look at. Even though it's PCI Express 3, we still need to look at it. Because as we know, as long as there's no PLX chip, the speed, which is dictated by 3 things. Number 1, the motherboard chipset. Number 2, the M.2 NVMe drives. Number 3 would be the card if there's a PLX chip, and we have no PLX chips. None. So if the card is defined as PCI Express 3 versus PCI Express 4, it doesn't matter. Okay, let's get our drives on. And the other 2 drives off the Supermicro dual M.2 NVMe adapter. That Supermicro is a stellar product. Okay, the Asus card is bare, so we'll get that back together so we can get it back in its home. Once I have this Asus card out of the way, I'll zoom in for a close-up on the Gigabyte card so we can focus on that. Asus was first in the market with a quad card, and Gigabyte, we didn't know what was going on, but when they finally came out with a card, they actually had about 3 or 4 that were used in demonstrations and presentations that never saw manufacture as a mass-produced product. But this is it, and it's impressive. Okay, a couple of distinctions. This has a fan. It's a smaller fan. This is a larger fan. This one has a couple of switches, and the reason for that is with those 2 switches, you're able to put multiple cards in a machine so that the software from Gigabyte, which I don't care for, can address the cards according to that fan if you choose to use it. But if you've got other software, and I've had some of you talk about it, that can address these fans, I would prefer it. I love Gigabyte hardware. I'm not a fan of Gigabyte software. Just my 2 cents worth. Okay, this card is done. And these are just little pads on here. Let me bring that back in right quick. On the Asus card, these are just little pads. They're not thermal pads. They're more like positioning pads, of which there are 4. And of course, you can see the links. We can go from 2242, 2260, 2280, and 22110. And as I remove that and we look, I'll take one of these off right quick. Same setup on the Gigabyte card. And yes, that is a pad. And yes, it sticks. You can tell when I set those drives down that they stay put. Got to get this Asus card assembled and out of the way so that we don't misplace any parts. I was really surprised, pleased, and impressed with the results that we achieved on the Asus. Knowing what we do with all the drives we've tested, with all the heat sinks we've looked at, I'm really curious now for the heat and speed test that we're going to do on this Gigabyte Aorus. And from what we've been able to determine, it looks like based on resources and speed that we're better off with 2 quad cards than 1 8-drive card. Yes, HighPoint and both Gigabyte have an 8-drive card. We've talked about that. We've done a video on it. And doing the math of what they've provided and what we've seen, those have PLX chips, which is probably a Broadcom chip, as we've talked about. Now the reason I mention that and bring that up, if you want to put 8 drives, 8 M.2 NVMe drives on a card, you're better off with 4 drives per card because of the switching of the upstream and the downstream ports. In other words, no PLX chip, so that all that's handled by motherboard bifurcation. Now, I did not mention it in the last video. I always do, but bifurcation is a key to making these work. I even had a comment, someone asking, why don't you do this on an X570 chipset? Well, we may do some stuff more as it relates to the X570. The problem is the X570 is a great chipset on paper, but the implementation is just, there's no dedicated resources. The way PCI Express lanes, slot and lane assignments are allocated on the X570 chipset is not conducive to the kind of things we want to do. In other words, you don't have a dedicated 16-lane slot. You have a 16-lane slot, but then when you use the second 16-lane slot mechanically, both become by 8 8 lanes here and 8 lanes here, because there's only 16 lanes that can be allocated. And when you use one slot, you got 16 lanes. But when you use 2 slots, you got 8 lanes over here and 8 lanes over there. So you can't use a quad card. Gigabyte does not have an X570 with a dedicated 16-lane slot. Asus, as I remember, and I may be wrong, has one motherboard that has one 16-lane slot dedicated. But then you've got the issue with the other slots. What you're going to do? Probably that second slot is going to be 8 lanes, and it's probably going to be for the GPU. So choices, decisions, options. So to reiterate where we stand with this, with a quad card, high-end desktop for PCI Express 4.0, because that question came up, X299, X399, that's PCI Express 3. For PCI Express 4, TRX40, and this happens to be the TRX40 Designare. Okay, if you're going to use one of these cards or even 2 of these cards, 2 16-lane slots, TRX40. If you want to go to 3 or 4 of these cards, WRX80. It is what it is. I'm just the messenger. And for the person that asked if I'd ever used 4 of these, which of course, to reiterate that, no, because you got to have a WRX80. One, we haven't built a WRX80, but do the math. If you got 4 drives per card, you got 4 cards, that's 16 drives. You're better off with resource allocation. I can understand 1 of these cards, maybe 2 of these cards. But beyond that, you're better off on a high-end GPU because it's about processing power. It's about rendering. That's just been our experience. So some things are theoretical and possible, but not all things are practical. Okay, memory's installed, and we can get the Gigabyte card in the machine as soon as we get the Asus card out of the way. Bag it and tag it until the next test. Okay, these 4 drives are Sabrent Rocket PCI Express 4.0 first generation, so they're capable of about 5,000 megabytes each. We'll see that on the test. So we'll establish speed and we'll establish heat, and then we'll see how the 4 perform. And then to reiterate, we'll take the top 2, which would be 1 and 2 here on the bottom, change them out for these 2 drives, and this will be in position 1, which will be on the bottom. This will be position 2, which is right next to it, and test again. So the first set of tests, 4 drives. The second set of tests, 2 drives, for a total of 6 tests for heat and speed. And the questions are going to be, what kind of numbers do we have? And yes, I have updated the chart. I've had some ask about, please publish that. As long as it's relevant, we'll keep putting the information out about it. So it's in the last video, but all the information from the last video is going to be in this video. When we get to it, I'll show you that chart. Stay tuned. Okay, our sandwich is complete. 3 pieces. I really like that metal backplate on there. Nice. It helps stiffen up the card and give it some rigidity. Somebody had commented about needing to use some kind of a GPU stiffener on the Asus quad card. Not an issue on the Gigabyte Aorus. Because the slot is already bifurcated in the BIOS, all I will do is go to the BIOS and verify that we see 4 drives from the boot menu, which will be 4 drives on this card, 5 drives total because of the one that's on the motherboard. Then we can go into Windows and give those drives time to enumerate. And if I'm not moving too quickly, they should pop up once the operating system recognizes them. Then we can do our tests. All assembled, ready to go. Now this particular cowling is plastic, but as you saw, the heat sink that covers the drives is copper machined, and then there's a thermal pad in the sandwich above and below. Okay, next step. Let's get this in the machine. And we are in the first 16-lane slot. Get the card secured. Okay, first 16-lane slot, the Gigabyte Aorus card. Second 16-lane slot is the EVGA RTX 2080 Ti, which is 2 slots wide. Then we have one 8-lane slot that we're not using right now, but we have used and done all our testing with a Supermicro dual M.2 NVMe adapter. And then in our second 8-lane slot, we're using 4 lanes, and the other 4 lanes we lose because this is Gigabyte Titan Ridge Thunderbolt 3 card. Thunderbolt 3, PCI Express 3.0, PCI Express 4.0, and that is PCI Express 3.0. And these, and the drives in here, all 4 plus these 2, which is 6, are all PCI Express 4. These are first generation, these 2, second generation. I'll go over that again later when we come to it because I think it's relevant. Okay, card is in, video card secure, plug in power, turn on, energize, powering up, Video card has power. We can see the post codes. We'll hear the post speaker. And as soon as it's up, we'll go to the BIOS. BIOS, boot, and we'll verify the drives. The boot drive, Seagate FireCuda 520 in the primary location underneath the quad card. And the quad card, of course, 4 M.2 NVMe drives that are bifurcated. And those 4 drives are the Sabrent Rocket 4.0 2 terabyte drives. 1, 2, 3, and 4. So all we need to do, F10, save and exit. Now this time we get through post, we'll go right into Windows. In fact, while we're waiting on this to boot, welcome to BuildOrBuy. My name is Gil Boyd. Thank you for joining us. We'll verify the drives. Windows flag E for Explorer. Click on this PC. Scroll up. And we can see our Sabrent disk 1, 2, 3, and 4. So we'll start with drive D for the test. We'll call up hardware info 64. We'll run thermistors only. And we're going to be looking at the smart telemetry for the sensors on the M.2 NVMe drives. First in the list, we'll see the boot drive, which is the Seagate FireCuda. And we're going to be watching temps on the 4 Sabrent drives. We'll start with drive number 1, minimum, maximum, and average. We're starting at 36 degrees, and we'll see where we go. We're going to call up Crystal Disk Mark. Now, all these drives are going to be 2 terabyte drives, so 2 gigabyte test file. All. Highlight hardware info, and let's watch our temps and see where we go. Now, while we're waiting on this to assimilate this information, we have a new chart update, and to the existing chart, I've added another chart on the right for the Asus HyperQuad x16, and then below that, we'll add another chart for this card, which is a Gigabyte Aorus x16 quad card. On a side note, I will mention, even though we're doing this as a standard test of what we've been doing, and the goal, of course, is to flush the cache, if we increase the size of that cache file from 2 gigabytes to, say, 4 gigabytes, we would get a better number on the reads than we are right now. But for consistency, we're going to keep this where it's at. And I had no idea we'd be doing as much of this as we are. I'm curious to see how this is going to compare to the Asus. Even though they're both quad cards, and even though they both require a 16-lane slot, it's interesting the approach that Asus has taken, and they are in their 3rd iteration of quad card, whereas Gigabyte with the Aorus has chosen a little bit different direction, and this is their first card. It's impressive. So we established these are PCI Express 4.0 first generation drives. We're just under the 5,000 megabytes on the read. We will establish our maximum heat once we get the second set of numbers on the megabytes on the right. Now, as a reminder, that first drive that we're testing right now, on the Asus card we had 49 degrees. And since this is more of a burst mode test, if we were to run this test 3 times in succession for a sustained throughput, we would definitely increase the temperature probably by at least 10 degrees, maybe more. So how close are we going to get to that 49 degrees? I have no idea. As always, throw the assumptions out the window. And the more of this we do, the more curious I become. I'm eager now to test some of the other quad cards that we have. Not only quad cards, but some of the other M.2 NVMe PCI Express cards that we have access to. Test is complete. We have achieved 49 degrees for our maximum temperature, which is on par with what we got on the Asus quad card. Okay, let's go on now. We've tested drive D. Let's do drive F. Highlight all. Test on drive 2 is complete, 53 degrees. And 53 degrees is spot on with what we had on the Asus HyperQuad x16. Fascinating. Let's go to the 3rd drive. Drive G, 2 terabyte, 2 gigabyte, all. Highlight, highlight. And the minimum, maximum, and average, we'll see where we go with this drive. Now, while we're waiting on this, drive number 3 came in at 49 degrees on the Asus HyperQuad x16. That's with the Sabrent, which is fascinating because so far, even though the designs are different, the results are the same. Fascinating. To reiterate, Asus uses the aluminum, whereas Gigabyte has chosen the copper. Details matter. Drive number 3 complete, and we topped out at 53 degrees. Fascinating. On the Asus, drive number 3 topped out at 49. Fascinating. Okay, let's go on down the food chain. Test the 4th drive, 2 terabyte, 2 gigabyte, all. Highlight, 4th drive, minimum, maximum, average. Excellent. 4th drive complete, and that test gave us 53 degrees. Whereas on the Asus HyperQuad x16, we came in at 45. Fascinating. I did not expect that. Very telling. Okay, the next step now is we need to take this machine, power down, get the other 2 drives in so we can test them, which are PCI Express 4.0 2nd generation. Let's take a look at the chart right quick. Okay, the Asus HyperQuad. We'll go 1 through 4. On the Sabrent Rocket 4, the first drive 49 on the Asus HyperQuad, on the Gigabyte 49. On the second drive 53, and on the Gigabyte 53. On the third drive at 49, and on the Gigabyte 53. And on the fourth drive 45, 53 on the Gigabyte Aorus. I think the Gigabyte has a superior design, but based on results, they're pretty close. But if you had to pick one over the other, the Asus is just a little bit better. That's fascinating. And to reiterate, that's Asus's third iteration of that card. So, power down, tap the power button, Windows is shutting down, turn off power, hold the switch and drain it, drained. Pull the power, capacitors are discharged, and now we got to pull the card. Open this thing up, swap 2 drives, 2 more tests. For those that might be wondering about the noise from the fan on this quad card, I don't hear it. It doesn't bother me. I've had some comment about it, and I got to tell you, I think what you may be hearing is the MOSFET fan. I don't think it's the fan on this card. That's just my take. If you install the software, then you can control the fan at your leisure. But without the software, it's running full blast, full tilt. The Gigabyte heatsink came off a whole lot easier. I think it's because of the thermal pad instead of the thermal strips that Gigabyte uses as opposed to the Asus. I'll get these ready, and since these are numbered from the bottom up, we will remove 1 and 2 accordingly. And they stay stuck down to that pad pretty good. Drive number 1, which will be the WD Black SN850, and then drive number 2 will be the Samsung 980 Pro. And I'll put those back on the Supermicro card for later. We'll get these 2 drives secure, test again, and we'll go back in the BIOS just to double check to make sure the drives are recognized before we go into the Windows, the operating system. Okay, all 4 drives are installed. Number 1, 2, 3, and 4 from the bottom up, heatsink, and the back plate. The nice thing about testing these 2 drives that are PCI Express 4.0 second generation, it gives us some correlation so we can compare results on our chart. This is absolutely fascinating. I had no idea when we went down this rabbit hole and in the weeds how far this would go, or how much interest you guys had in this. But then again, I thought quad cards was a esoteric topic in the first place, so what do I know? But you guys ask, we deliver. And I hope by doing all these, it will help to drive home the point. Yes, there's a lot of interest in this, but because there is so much interest, what is required to operate one of these? What kind of computer? So you understand resources, PCI Express resource allocation. As one subscriber pointed out, PCI Express resource allocation is kind of like used to when we talked about IRQs. That's been a long time ago, but that's what this reminds me of. Card is reassembled. I would have thought with a bigger fan, and I would have thought with a copper heatsink, that the Gigabyte Aorus would get better results. But, okay, back in the computer. I think we also need to point out that we're putting single-sided drives on these cards. And I think it would be a problem to try to use double-sided drives on these quad cards. To do so on the Gigabyte Aorus quad card would require removing that bottom thermal pad. To do it on the Asus HyperQuad by 16 would require those little bitty pads that they had on there that are more like spacer pads. But from what I've seen, the quad cards are definitely made for single-sided drives. Okay, card is secure, video is good, plug in power, turn it on, energize. And as soon as the BIOS comes up, we'll go back in. I just want to identify the drives. Waiting on post. Video's good. BIOS codes are good. And we hear post. BIOS. And to reiterate, we do not need to check or double check bifurcation. That's already set. I'm just going to tab over here to boot. And we see, yep, there's the Seagate FireCuda. And for number 3 and 4, it sees the 2 Sabrent Rocket 4.0 2 terabyte drives. And then for option 5 and 6, which is actually on 1 and 2, we see the WD Black SN850 and we see the Samsung 980 Pro. Verified, F10, and reboot. So we see our 4 drives. We know we got power, watching postcodes. We'll hear the power on self-test from the PC speaker. We'll go past the BIOS into Windows. 2 more tests. Fascinating. I got to interject while I'm waiting on this to boot. I had a really nice Windows install on that quad card that I had to destroy so we could do this heat and speed test. We cannot get drive telemetry with the AMD Hybrid BIOS bootable RAID, Windows. All this for testing. Okay, first things first, Windows flag E, this PC. Yep, drives popped up. And if they go away and come back, we'll have to give them a minute because I'm moving kind of fast. Okay, WD Black SN850 is at the D drive. Samsung 980 Pro is the F drive. Fantastic. Yeah, they went away. Okay, just to verify then, I will go ahead and go into disk management, control panel, administrative tools, computer management, disk management, just to verify the drives. There's the WD Black SN850, and there's the Samsung 980 Pro, DNF. Okay, good. I'll close all that. Hardware info, sensors only for telemetry from the smart thermistors. We'll scroll down and find the drives. There's the boot drive, Seagate FireCuda, and there's the WD Black SN850, and there is the Samsung 980 Pro. Okay, we're going to start with the WD, crystal disk mark. Now these are 1 terabyte drives, drive D, and we'll do a 1 gigabyte test file, all, highlight. First thing we'll establish, ouch, well that's a new one. I didn't expect that. That's a 2nd generation drive, and that's only getting about 4,000 megabytes on the read. That's most curious on the WD Black SN850. And remember, position 1 on that card is at the bottom closest to the PCI Express connector. That should not give that kind of result. So the problem could be because that drive requires a firmware. It has not had the firmware update done. However, that should not matter going to the CPU. But it may. But that should have come up at 7,000 megabytes. It did not. So it'll be curious to see what kind of temperature we get, because on the Asus Hyper Quad card, drive number 1 came in at 49 degrees, and right now we are at 56. Wow. I'm going to be even more curious now when we do the Samsung, see what kind of numbers we get off of that one. I'm curious now if we install the firmware update on that drive, if we will see a performance improvement. Now, if we run that test again within, say, 8 hours, we will be at a different heat point. So the heat would not be accurate, but we would be able to verify if the firmware update, to reiterate that fact, changed that read speed, because that's a 7,000 megabyte drive. And in that first position on that quad card, we're not even getting 5,000 megabytes. Wow. Did not expect that. We did not have that with the Asus card. As I've said before, the more I learn, the more I realize how little I know. And the more I know, the realize I need to know more. Okay, test complete. We are at 58 degrees. Wow. That got hot. And on the Asus HyperQuad x16 in that first position, the WD Black came in at 50, and this drive came in at 58. Okay, let's test the next drive. Drive F, 1 terabyte drive, 1 gigabyte test file, all. And we will highlight. And remember, there's 2 thermistors on the Samsung 980 Pro. The primary that we're going to watch on the drive, that's on the memory, and then the second one that's looking at the controller chip. And the Samsung 980 Pro on the Asus HyperQuad x16 in that second position came in at 49 degrees. Performance is a little bit better, which is about on par with a Samsung. I think the WD Black needs a firmware update. I mentioned that firmware update because if we were using this drive on, say, the X570 chipset specifically, if the drive is on a motherboard that has the X570 chipset, but if the drive is to the CPU, it would not be affected by that performance degradation. However, if it's on the chipset, which is a little bit slower, it would be. And for some reason, something is affecting performance of the WD Black on the Gigabyte Aorus. And my only solution is the firmware update. We should not be having a load balancing issue. That's why I kept 4 drives on the card. However, you see the numbers. Most fascinating. Okay, test is complete. We now have the stats for the Samsung 980 Pro. We topped out at 61 degrees on the Gigabyte Aorus, whereas on the Asus HyperQuad, we came in at 49 degrees. That's quite a difference. Let's take a look at the chart. On the left, we have our 12 heat sinks that we have tested for M.2 NVMe PCI Express drives. Number 1 is the WD Black SN850 at 92 degrees bare, and that is bare on the Supermicro dual M.2 NVMe adapter. Number 2, the TRX40 Designare second heat sink, and that second heat sink will be that location where nothing is at, because we still have some more heat sinks to test. So in that location, with 1 thermal pad, we came in at 65 degrees. Then going down the list where we have, for example, 10 and 11, that's the Neo aluminum, active and passive. Our best, however, was number 5, the Sabrent Rocket 3 heat pipe at 54 degrees. And then the number 1 on that was the number 9, Acetylene 4 pipe at 48 degrees. Our numbers we've had the best of have been on the Asus HyperQuad, and the most consistent numbers that we've had as we've gone through 6 different tests. I find that absolutely phenomenal. We're still in a good position and in a good place putting drives on a quad card. However, I am floored on these numbers. It just didn't expect that. You know, again, I always say throw all the assumptions out the door, but this is most perplexing on the WD Black. So the only solution we have, let's check that firmware update, see if it does us any good. Now, the temp we're going to get is going to be different. It's going to be higher. Could be 3 to 5 degrees higher, but we'll see because, again, we're running the test in succession, so this will be test number 2. And running the test in succession like 3 times would be more like a actual throughput. These tests are burst mode. That's the way we've done everything to keep it apples and apples. But let's try the firmware and see if it makes a difference. Only way to find out is to try it. So first thing, Windows flag print screen. We did a screen capture. And I'm going to double check without closing these down and see if I have Windows flag E, that application on the drive. I don't remember. Dashboard setup. I believe dashboard. Yeah, Western Digital. It's here. I've looked at so many drives with so many different installations. I don't remember what's on what drive till I call it up. Okay, what we want to find, and it went right to the drive. Look up here at the top, and it found the WD Black SN850. Shows the firmware version. It says drive healthy, security, frozen, new application available, new firmware available. So I'm going to get the new application first. A new version of dashboard is available. So before we update the firmware, we'll update the dashboard control panel. I have Windows installed on a 2 terabyte drive for this machine. I have Windows installed on a 4 terabyte drive for this machine. And I had Windows installed on the quad card in RAID, which is now gone. Relaunch dashboard. And up here at the top, model WD Black SN850 shows the firmware version. And it says new firmware available. So we'll click on that. And it shows us new firmware available. Create a bootable drive. Update using file on the computer. So we're going to update the firmware. Disclaimer, there's a risk of complete data loss when updating firmware. Amen to that. Therefore, it is strongly recommended that you back up your data before updating your firmware. Please ensure your system is connected to wall power during the entire firmware update process to prevent the update from failing. Have you read this warning and do you want to proceed? Proceed. Please wait while the firmware is updated. The firmware update was successful. Please click rescan to proceed. Rescan. Firmware is up to date. That was painless. And it shows up here at the top. We have the current firmware version. And I'm curious about performance. And I'm curious about temperature. It says the temperature is at 49 degrees. So I'm good with that. So I'm going to go ahead and close this out. And then I'm going to rerun that test. Now our temperature is going to rise. But what I want to find out is, because of the firmware update, will we be able to get drive D, which is the WD Black SN850, back up to the 7,000 megabytes on the read? So to reiterate, 1 terabyte drive, 1 gigabyte test file, all. Let's see. I probably should have made that a separate video, but since it happened with the quad card, we need to see if we can address it. Wow, that's terrible. It cut performance in half. Unreal. So the moral of that, think twice before you update the firmware. Wow. That's pitiful. I've warned of things like that in the past, and now you can see why you always want to be careful if you update the firmware on a drive. That was a drive that was capable of 7,000 megabytes. It is now reading on that card at not even 3,000 megabytes. That's terrible. What we may need to do, since we've updated the firmware, is power down the machine, clear the power, reboot the machine, then reinitialize the test. And the next option after repowering the system and testing again would be to put it back on the Supermicro dual M.2 NVMe adapter and test it and see what kind of numbers we get, because we know what we'll get there. Just over 7,000 megabytes on the read. But that's pitiful. Yeah, that's terrible. Even the writes are bad. 3,500, wow. 3,600, that should be coming in just under 5,000. But I need to power down first and reinitialize the disk. Not reinitialize as in reformatting the drive. I just need to remove power from the drive and repower the drive. We'll see if that restores performance. Temperature still looks pretty consistent. We're still coming in at 58 degrees, which is what we had a while ago. Test is complete. Look at that performance. That's terrible. Temperature is fine, 58, that's consistent, but look what we did to the performance of the drive with that firmware update. Okay, change one thing changes everything. Now that I've done it, you'll have to think twice, because I always said be careful because you might hurt performance on a drive, and sure enough, we hurt performance, but we got to reboot. So we'll do a screen capture first. Fascinating. And we need to tap power. Shut down, turn it off, drain it, capacitor is drained, turn it back on, power up. Okay, we've drained the power, so we'll go right back into Windows and retest and see if we've got performance restored or if performance is still degraded. Nothing ventured, nothing gained. Post. Lucy, you got some explaining to do. Now, for those that are wondering while we're getting this up to boot about the fan on the Gigabyte Aorus card, I don't hear it. What I hear is the MOSFET fan. That's the one making the coil whine, because I've had some complain about the fan on the Aorus quad card. It's the MOSFET. Okay, Windows. Hardware info, third time's a charm, sensors only. We'll scroll down and find the WD Black SN850. Well, when we have problems, that's how we learn when things don't go right. Crystal disk mark, and we'll double check Windows flag E, this PC, and yes, the WD Black SN850 is still drive D. Verified, drive D, 1 terabyte, 1 gigabyte, all. And we'll see if we get this back up to 7,000 megabytes on that read. Perfecto. Wow. I don't know about you, but that kind of freaked me out. Okay. So I think we learned a lesson there. Whenever you update firmware on an M.2 NVMe drive, power down, remove all power, drain those capacitors, power back up, check it and verify it. I'm going to let this finish just to make sure, because what we're looking at is we verified 7,000 megabytes on the read, but I want to double check the write and see if that's back up to also about 5,000 megabytes. And our temperature is going to come in hotter, which was expected. So there's not really a correlation with that temperature. I will not record it. I'll just mention it here. Right now it's 66. It's going to get hotter. But remember, we've done this test in succession, all in the name of research for you guys. I got to tell you, I was sweating bullets on that one. I thought, well, that's a bummer. So for those of you that did not catch the reason and the results, whatever's going on with the WD Black SN850, especially on the X570 chipset, but as it relates to the Gigabyte Aorus card, if you're not getting the right performance out of that drive, you may need a firmware update. And that's what we did. You saw the results. You see where we're at. Yeah, okay. The writes per megabyte, I'm good with that. But I'm going to let it finish. In case anybody is wondering, the issue is really not with the Gigabyte Aorus card. There's something with the timing issue on the WD Black. It was just sensitive for the X570 chipset, and it's also apparently sensitive to the Gigabyte Aorus card. So if somebody asks, would I put 4 drives on that card, the WD Black, specifically SN850? Absolutely. But just test, verify, do the firmware, and power cycle it. Drain it. Okay, test is complete. We topped out at 66 degrees. And again, to reiterate, there's not really a correlation for the temp based on we've done this in succession. What the purpose of this was, though, we have, to reiterate that fact, restored performance of the drive. So if we look at our chart again, for those that want to do a screen capture of this, numbers 1 through 20, drive number 1, the WD Black SN850, at 92 degrees bare on the Supermicro dual M.2 NVMe adapter in position number 1. And then number 2, to reiterate that, on the TRX40 Designare second heatsink, which would be in that position on the motherboard that's open because we got some more testing to do. That came in at 65 degrees. And you can look through the list. To reiterate, the Sabrent Rocket 3 heat pipe at 54 degrees. And then number 9, the Acidity 4 pipe at 48 degrees. And looking at the temps on the Asus, we have the most consistent temps on the Asus HyperQuad by 16. The temps we got with the Gigabyte in position number 1 comparing to the Asus, I'll go through these numbers. Position number 1, 49 degrees, 53 degrees, 53 degrees, and 53 degrees. And then for drives 5 and 6, starting at the top, the WD Black that shows on the Asus HyperQuad at 50 compares at 58, and then the Samsung 980 Pro at 49 on the Asus, on the Gigabyte Aorus 61. So the takeaway, I think both cards are pretty equal, but the temps are better on the Asus, which I did not expect. Aluminum heatsink versus a copper heatsink with dual thermal pads. So go figure. But we could improve performance by changing out the thermal pads if we chose to. So this is Build or Buy. My name's Gil Boyd. I want to thank you guys for watching. We're on to the next video. We're out.